the another session of our data structure journey. So we have already covered array and linked list in our previous video. So today we are going to cover that is the stack. I have already covered various operation as well as the application of array and linked list in my previous video. If you want any application or any type of problem I should cover in my videos or in for by using the linked list or by using the array, you can just write down in comment section. I will try to cover in my coming video. So let's start. So first we have to know what is a data structure. So data structure means how we organize the data in such a way that we can retrieve the elements in the efficient way. So whenever we are going to retrieve the data, main objective, our time consumption as well as the space consumption should be less. So on that basis, we are classify our data represented into the different type of structure. Stack is one of that type of structure, which is a linear data structure. Linear data structure means all the data present in stack is a one line format. That's why it is called as the linear data structure. And all the operation it performs in a particular order. So there must be some order. What is the order? Order is that last in, first out, or first in, last out. Last in, first out means the element inserted last is going to be deleted first. Or the son of elements means list of elements where insertion and deletion means adding and deleting an element is can be done from one end, and that end we call as the top of the stack. So stack is nothing, it is a collection of elements which is stored in a linear format where insertion and deletion can be done from one end. That end we call as the top of the stack. Next, what are the basic operation? Means what are the operation we can perform on the stack? So first operation is the push. Push means how to insert an element into a stack. Next one is the pop. Pop is how we can able to remove or delete an element from the stack. Another operation, basic operation is the push and pop. Remainings are also pop, operation of the stack. So is empty. Is empty is we are going to check whether our stack is empty or not. If it is empty, the function returns the true value. Otherwise, it returns false value. Next function is or next operation we have to perform, that is full. We are going to check stack is full or not. If stack is full means we cannot able to insert data or we cannot able to add the data. For that reason we are going to perform this operation to check whether our stack is full or not. If the stack is full, then the function is return value is true. Otherwise the function return value is false. Then pick means the operation, that the pick is the operation is used to retrieve the topmost element present inside the stack. Last one is the display. Display means we are traversing the entire stack to print what are the element present inside the stack. So first operation of the stack is push operation. So push operation means that we are going to add or insert an element into a stack. So this is our algorithm. So first we have to check whether it is full or not, means that if data is available or not. If the data is available, if space is available, then only we can insert the value. So as we know, stack is a collection of elements. For example, this is our stack. One stack is present. There are stack size is 5. So the stack can store the maximum 5 elements. For example, element store 10, 20, 30, 40, 50. This is our stack S1. As we know, insertion and deletion is always done from the one end and always the pointer points to the top of the stack. So this is our top. Top is the position of the topmost element. So now the stack is 5, consists of 5 elements. For example, I want to insert 60. So insert 60 means what? Stack is full. So stack is full means we cannot able to insert 60. So this is the condition. First we have to check whether any space is available inside the stack or not. If space is available, then only we can insert. So this is the maximum 5 element it can store. So this is 0, 1, 2, 3, 4, location. And this, so top is right now points to the fourth location. That is the top value is right now 4. So for example, this is another stack is present, that is S2. Right? There is no element present inside the stack. So now top is points to, for example, initialization value is -1. So always we make the top, means top of the stack is -1, because there is no element, and indexing starting from 0 to size -1. That's why initialization of the top is -1. So for example, we want to insert a value. So what we have to do? Top equal to top plus 1. So now top value initialize, right now value is -1. We have to increase one value, means -1 to this position. This is the 0, 1, 2, 3, 4. So for example, we want to insert the value is 11. So now 11 value stored inside that. This operation we call as the push. Means inserting an element into the stack we call as the push. So whenever we are inserting an element, we have to think that whether any space is available. Right, top is equal to -1, so space is available. So if the space is available, we have to increase the top size by 1. Then we have to store the data into the top of the stack. Then we have to end the procedure. So for example, again I want to insert a value. For example, right now I am to insert the value. So what I have to check, if stack is full? No, stack is not full. Space is there. So what happened? Top equal to top plus 1 inside the store. So top is right now 0. So now it points to this pointer. Now top points to this one. Now this is the top points to index 1. Then stack index 1, we have to store the data. That is the value 22. Similarly, we store 33, 44, 55, 66. So for example, this is the array. Now how many element it can store? That's the 6. For example, S2 stack size is 6. So now again we want to insert the value, another value, for example 80. So whenever we try to insert an element, that time the operation we called as the push operation. At that time we have to check space is there or not. No, space is not there. Already stack is full. So stack is full means we cannot able to insert the value. So this is a very simple algorithm for the push operation. For inserting or pushing an element into the stack, two things we have to check. First case, this is the case 1. Case 1 to check whether stack is full or not. Case 2 is the if stack is the full, we have to simple return. We cannot insert the value. Case 2 is that if the space is available, we have to increase the top value by 1, means the top points to the next value. Then the store the data and we have to return. This is the algorithm for the inserting an element into the stack or push operation done by the stack. So next operation is pop. Pop means the operation is used to remove an element from the stack or deleting an element from the stack. So this is our algorithm. Here also same thing, we have to check whenever we are going to remove or delete an element. First we have to check whether the stack is empty or not. If the stack is empty means we cannot able to delete an element, because if there is no element present inside the stack, we cannot able to delete the element. So for example, this is our stack. So right now top pointer value is -1, because right now top point to this one. This is our S is our stack. So if we go for begin, if stack is empty, return null. Each stack is empty. How to check? If top equal to -1 means there is no element is present. So top equal, whenever top equal to -1 means there is no element which present inside the stack and we cannot able to retrieve or perform the pop operation. Such type of situation we call as the underflow. This condition we call as the underflow condition. So this is the underflow condition. For example, we insert the value 10. So whenever we insert, two step we have to follow. We have to increase the top value to the by 1. So this is 0 index. Then we have to insert the data. For example, again, we insert the value. We perform the push 10. Then we perform push 20. Then we perform push 30. So now top value is 0, 1, 2. So top value is 2. So if we want to go for pop operation, right now we want to go for pop operation. Pop operation. So what happened? We have to check stack is empty. No, stack is not empty because top value is 2. Means there are 3 elements is present inside the stack. And then what we have to do? Data. Data is the variable where we have to store the stack top. What is the stack top? Stack top S is the stack is the S. Top is 30. So data store the 30, then top equal to top minus 1. Previously, top points to this value. Right now, top is top minus 1 means this pointer right now points to this location. So pointer value also change. So previously the pointer points to this location. Right now the pointer top points to this location. After the decrement value, the pointer points to this location. Then return the data means we are returning the value 3. So whenever we go for pop operation, which value is deleted? 30 value is deleted. So this is the way we can go for the pop operation of the stack or deleting an element from the stack. So what we are observe here, whenever we are inserting through the this operation means this is called as the push. Whenever we are go for pop operation, then what happened? Only the topmost is element is going to be deleted. So for insert and delete, only one end we are using. So that end we called as the top of the stack. This is the concept of the stack. Collection of element where insertion as well as deletion or push and as well as the pop operation is going to be one end, and that end we called as the top. And the top initialization is -1, and whenever we are going to insert the data, we have to increment the top value and store the value. Whenever we are deleting, so first we have to store the value of topmost element into the another variable, then we have to decrease the top of the value. So this is the very simple logic we have to follow for the push as well as the pop-up. Next operation is empty. This function is used to check whether stack is empty or not. If it is true, it returns true. If the stack is empty, otherwise it returns false. Let us understand the concept first. For example, this is our stack. Stack size is 5. So 5 element we can store inside the stack. These are the indexing 1, 2, 3, 4. So total realization means always the insertion as well as the deletion can be done from one end. So insertion we called as the push, deletion we called as the pop. So both the operation is done from one end, that end we called as the top of the stack. So whenever there is no element, so at that time top should be point to this one. Top means this is 0, this is -1. So initialization is -1. So begin procedure of is empty. If the top less than 0 means this is the starting indexing 0. If it is less than 0, then it returns true means our stack is empty. Otherwise, it returns false. So next operation is full. Is full operation to check whether stack is full or not. It returns true if the stack is full. Otherwise, it returns false. So this is the algorithm we have to follow. If top equal to maximum size. So here 0, 1, 2, 3, 4 maximum size is, the size maximum is 5. If the top equals to, right now if the, for example in this case, right now there is no element. So what happened? We are inserting the value. So for example, we push value 10, then 20, then 30, then 40, then 50. So after that, if we want to check whether it is full or not, if it is full, is equal to maximum size means maximum size right now it is maximum size because already it is 5. So max size is always the length of size of the stack -1, then it returns true, otherwise it returns false. If it is full means we cannot able to insert. This condition we called as the overflow. This condition we called as the overflow. So whenever maximum size we called as it is a overflow condition. Peak. Pick operation used to return the top value of the stack without removing any element from the stack. Means here we are not going to insert any value or we are not going to delete. Simple, we are just retrieve the value from the top of the stack. Just we want to know which value is present in the top of the stack. So for example, this is our stack is given. This is our stack with 5 elements 10, 20, 30, 40, 50. Return, so begin return. So procedure we have to follow. Pick, return, stack, top value is right now 4, so it will retrieve the value. So it will retrieve the value 50. 50 is the topmost element present inside the stack, but it will not going to remove or anything. Without removing the element, it will be retrieve the value. So this is the basic difference between pop. If you go for pop means it retrieve the value, but if you go for pick means it only retrieve the information stored inside the topmost elements. Next topic we have to cover, that is the type complexity of stack operation. For push operation, order is 1. For pop operation, order is 1. Is empty also order is 1. Is push also order is 1. For pick also order is 1. So how it possible each and every operation is order 1 except the display. Display is n. N is reason that because we are traversing the n number of elements. So for traversing it requires 1 constant time, and if you go for the traversing n times, so it will 1 into n, that's why it is n. Let us understand how it's possible that each and every operation is requires constant time. So for push operation, what happened? For the return, it will return at one constant time. So if you go for push operation, for each and every time, only these two statements should be executed. So for that, it's required only one constant time. That's why the time complexity is order of 1. If you go for push operation, then what happened? If it is empty return value, so it is a constant value. For pop operation also these two statement we have to execute. So it also requires only one constant time. That's why the time complexity is order of 1. If we go for is empty also is empty, it is returns true or false, one constant time. If you go for is full, it has to check the whether it is equal or not, then it return value true or false. Also it is a constant time. If you go for peak time means only this statement it has to execute, so only one fixed time is required. That's why the time complexity of each and every operation in case of stack is order of 1 except the display. For display we have to traverse n number of elements. That's why to traversing one element it is a one constant time. For n it is order of n. Next we have to know what are the advantage of stack. First one is the simplicity. Stacks are very simple to understand as well as the implementation. That's why we can able to use in wide range of application. Second one is the efficiency. Here what happened, the time complexity for push and pop operation is only order of 1. So which provides us efficient access to the data. This is the main advantage because time complexity is constant. So next one is the preventing overwriting value. So here what happened, whenever we inserting, we can insert the data or we can make the new elements. But whenever we go for the deletion, at the time what happened? Deletion can be done from the one end and the only the last element it can be deleted. Whenever we are inserting elements, so we can insert as per our choice. But whenever we go for deletion, we can able to delete only the topmost elements. So what happened? It ensures the data integrity because if you write accidentally overwriting information in case of the memory allocation or anything, so it will not happen to the all the data. It will happen to the topmost element only. Limited access and manipulation. Only accessible is given to the topmost element. We cannot able to access the remaining element present inside the data for the unnecessary access. So this is the main advantage of stack. So recursion. So here what happened, the stack are inherently recursive data structure. So whenever we are using the recursive algorithms, what happened? The process is unwinded after reaching the base class. So what happened in case of recursion, each and every recursion stores state into the stacks, and once it completes, it will go for popping operation. So one by one, whenever we are executing, it will go for push operation. Whenever it's end, it will be perform the pop operation. So it supports the recursive the procedure. Next advantage is the speed, because here we are can able to implement the stack by using array as well as the by using linked list. Whichever we are using, it is very fast. Reason is that insertion and deletion is going to be from one end. That end we called as the top of the stack. Next one is the disadvantage of stacks. Here what happened, random access to element inside the stack is not possible. Means whenever we want, we cannot able to access any position element. We can able to access only the topmost element. This is the main drawback, because we cannot perform searching an element. If you go for searching an element, what happened? We have to perform multiple iteration for entire stack. So that is the main drawback of the stack. Second one, difficult to protect the data. Reason is that it only exposed to the topmost element, means that lower protection stack can be other data structure. So if any accidental corruption or anything happened to the topmost element, then what happened? Remaining data we cannot able to recover it. This is the main drawback. Memory inefficient stacks are pre-allocated, means whenever you go for the stack, how much element we can store, we have to maximum size we have to define. For example, I define the maximum size, that is the 50, and I store only the 5 elements. Then what happened? Remaining 45 storage is used. This is the case of array implementation. So to solve this problem, we can go for the dynamic memory allocation, that called as a dynamic stacks, which helps to increase the memory efficiency capacity. One more problem is that there is a stack overflow. If the stack is full, we cannot able to perform the push operation. This is the main drawback. Overflow may causes crashes in applications such as boundary checks are implemented, because for the overflow condition we have to go to check the. So whenever we write an application, at that time if you go for multiple time the boundary check operation, then what happened? There is a chances of crashes. Stack one more advantage is that what are the constant on uses, the LIFO structure, that is the last in first out structure, intentionally restricted how the stack can be used. Means how internally it is going, we don't know. We are only insert the delete. So here we cannot perform the sorting or swapping elements. We cannot able to perform. There are the restriction limit. That is the main drawback of the stuff. So here what happened, whenever you go for debugging, it will take more time, because stacks can be tracking only, it can be done for the topmost element. We cannot able to go to the any other element present inside the stack. So it is not that much cache friendly. The continuous push and pop operation make the stack access memory in the last in first out order, which is the opposite to the cache access pattern. So this is the totally opposite to the. So hit what happened is misalignment leads to the frequent cache miss, if we, which leads to the what, the performance of the stack program is down. So these are the disadvantage of the stack. Next one is the application of the stack, means where we can use the stack. So expression evaluation. So arithmetic expression, it can be evaluated by help of the stacks. It can be prefix, or it can be postfix, or it can be infix expression. We can able to evaluate any expression by help of the stack. Function call. Stack is used to keep information about the active function or subroutines in a program. Parenthesis check. So whenever we writing any expression, it can be any number of opening bracket and closing bracket. So here what happened? We are going to check whether properly opening bracket is present or closing. But as per the parenthesis or as per the rule, opening bracket parenthesis should be matched with the number of closing bracket. If it is not matched, then what happened? Expression is wrong. So this can be also done by help of the stack. So expression conversion means an expression can be represented in prefix or postfix notation or infix notation. So stack can be used to convert infix to postfix, infix to prefix. So these are the conversion. Expression conversion can be possible to the by help of the stacks. We will cover all the details in upcoming video. Next application, syntax parsing. Many compiler use the stack for parsing the syntax of expression, program blocks, etc. before translating into the low level code. String reversal means we can able to convert any string into reverse string by help of the stack. We can able to do it. So after implementation of the stack as a array and linked list, we will cover all the application in our upcoming video. Next one is the backtracking. Suppose we are finding a path to solve a match problem. So we choose the path and after following, we realized it was wrong. So here what happened? We cannot able to go from one path to the another path. So how to do it? So we need to go back to the beginning path. So what happened? This can be done by help of the stack. So this is the one category of stack application. So these are the all about today session. So we cover what is a stack, what are the operation of stack, then advantage, disadvantage of stack. Then we cover what are the application of the stack in. So in upcoming video, we'll cover how to implement stack by using array as well as the stack linked list. And then we will cover all the application of the stack by using linked list or by using the array. Thanks for watching the video.